Hi, in this video, I'm going to talk about Facebook Profit for time series modeling. Now, before going into the details of Facebook Profit, I'm going to just explain the data set that I'm going to use for this particular video. So the data set I have is New York electricity demand data set. So this is basically the demand of electricity in New York City that you can see on over the graph here. Now, I have explained this data set in detail in my previous video where I built an ARIMA model. You can check that particular video. The link is on the top. You can click the link and check it. I'm not going to go too much detail into the data set, but just going to give a quick overview of the data set so that it will be helpful during the modeling process. And in this video, I'm going to focus on univariate modeling. In the next video that will be coming in the future, I will be focusing on multivariate modeling. Right. So now if you see, this is the variable that we are going to model, that is the electricity demand. And this electricity demand, there are other columns, which is the precipitation. We are not going to use it, and we are other column is temperature. Now the data is between 2012 to 2017. Now, if you see the temperature, as the temperature rises, you can basically see the electricity demand also goes up. So basically, typically that summer month, like people will be using a lot of appliances to keep them cool and everything. So as the summer month nears, the electricity demand is also high, and then basically it comes down during the winter month and again during the summer. So you can see there is some correlation between the temperature and your output demand. Now we are going to only use demand to model in this case. But as I said in the future video, I'll use both temperature and demand to model and compare the models, like how without temperature it works, and with the demand and temperature together, how is the prediction. So this is the data set. The file for the data set is available in my GitHub repo. So this is my GitHub repo. You can search it, and there is an NYC energy consumption data set that is available, which you can download and which you can use it. Now coming to the modeling part, again this data set that is there is by default at an hourly level. So the energy consumption is captured in New York City for every hour. So for this modeling, what I have done is I have just aggregated this into a daily level. So for that, what I am doing is I am using like resample of the data set. The data set is in the NY data frame. I'm just using resampling it and resampling it at daily level. So the 24 data points that is there per day, that is hourly data point, will get aggregated into a daily value, and you'll get a timestamp column. You will have the demand column. You have the other two columns. As I said, these two columns I'm not going to use for this video. So I'm going to predict the demand only based on the prior occurrence of the demand. There is seasonality, which we saw. Basically, here during the summer month, there is an increase in demand. So there is some seasonality. We will see like how we can model this particular data. I'm going to take this resample data, and then I'm going to basically assign it. This is the daily level data. So if you it's the same thing I spoke about, but if you see on the top, it was hourly and it was pretty dense. But here, when I aggregate it into the daily, it's better to visualize it. It's a daily level data. I'm going to assign it to an N by DF daily data frame. That's what I'm doing. The same resample, and I'm going to assign it to that. Now, if you want to learn more about Facebook Profit, this is a very nice paper that they have published that you can learn over there. But just to give you a quick idea, this is the kind of how Facebook Profit works. Basically, this is the it's a combination of trend, seasonality, holiday information that we give, and the final residual. So y of t here is the variable we are going to predict. That is our forecast that we are going to do. G of t is the model trend, right? It's the model non-periodic changes in the value of the time series. So this is a trend component over there. Now, the trend component in this case is basically can be a piecewise linear regression model, which is a default model, or it can be a logistic growth curve and model. Now, Facebook Profit automatically detects the changes in trend by selecting the change points, and this change points comes with the piecewise linear regression model that it runs internally. That is the trend component. The seasonality component is basically your periodic functions that take into account, right, like the monthly, weekly, or yearly seasonality. In our case, there is an yearly seasonality over there. Now, by default, Facebook models additive seasonalities. But sometimes what will happen, there will be a trend in the, there will be a particular growing trend in the incoming data set, right? So in this video, video, the data set I have chosen does not have any trend. Basically, the data is stationary around its mean. But sometimes you can see the data increasing over time. Like if you take Amazon revenue data set that I spoke about in my previous couple of videos, you can see the revenue is constantly increasing over time. So there is a trend as well as there is a seasonality, right? So when you're talking about additive model, this may not be modeled properly, and that's why the multiplicative model comes into play. But the multiplicative model I will be covering in my video, where I'm going to talk about the trend modeling using Facebook Profit. And the final one is holiday. The holiday is basically, sometimes you may have like retail sales spike up during any holiday season or during the weekend. It can be your Thanksgiving, Christmas, or it can be Saturday and Sunday. So you can give explicit dates to the model to dictate some trend change and behavior. That is the holiday. And finally you have the residual, which is nothing but the final error component of the model, and it's assumed to be always normally distributed, right? So these are the different components of the profit model. It is based upon the Stan library, which is nothing but a probabilistic programming model library, right? So now let's get started with it. What I'm going to do is, first I'm going to import profit. So from Facebook Profit, I'm going to import profit, and then what I'm doing is I am converting the column names. So the way Facebook works is, now the input to the Facebook is always a data frame with two columns. One is the timestamp column, which Facebook requires it to be named as DS, and second is the target column, which is the demand in our case, which Facebook expect to be named as Y, right? So that's what we are doing here. What we are doing is we are taking this NYDF daily data set that we created on the top. We are taking the timestamp and demand column. We are leaving out temperature and precipitation for now. We are renaming the timestamp column to DS and the demand column to Y. So that's what we are doing over here. Let me run this, and once I run the output, you can see basically there are two columns now. You have DS and your Y. So Facebook expects the input columns to be in the with this name, right? And you can see there are some null values. Typically, when we developed an ARIMA model, we handled the null value. But in case of Profit takes care of handling the null value, so you can leave it as it is. But ideally, you may want to even impute it based on your business understanding, which the model, which the Facebook Profit tool might not be aware of. So it's good to impute it, but otherwise you can leave it as it is as well. I'm going to leave it for now. Then what I'm doing is I'm splitting this particular data set into train and test. So I'm taking all the data that is between January 2012 to April 2017 in the train data set, and after April 2017 I am putting it to test data set. So let me do that, and let me quickly check the shape. My training data frame has two columns, that is a timestamp and the target demand column, and then it has 1947 rows, and the test has around 104 rows and two columns. So this is the test data set that we have. So we are going to go and model with this. So the very first thing I'm doing is I am initializing the profit, basically the profit model, right, which is assigned to M, which is nothing but the output model. And I can leave it as it is. You don't have to do anything, just give an empty constructor over here. But in this case, what I'm doing is I'm telling to create a model with a confidence interval of 95%. By default, Facebook creates with 80%. If I don't give this parameter, it's going to create with 80% confidence interval. I'm just telling the interval with us 95%. Yearly seasonality, I'm telling it's true because I know the data set, there's a yearly seasonality. The demand increases during the summer month. I'm just giving yearly seasonality true. You can leave it. Facebook will find it by itself. By default, it is auto. So Facebook will look for yearly seasonality, monthly seasonality, daily seasonality, depending on your data. But here, since I know it, I have already given these two parameters. And then what I'm doing is, once the model object is defined, I'm just doing a model.fit of train object. So the train object is the data I created between 2012 to 2017 April. I'm going to fit the data over here. And now the model is fit and run. And let me quickly check the model parameters. These are the model learn parameters. I will come to this later. But these are different model learn parameters if you want to check it out. As I said, it's going to create a linear model, so you can assume it kind of a coefficients over there. Now what I'm doing is, now I have the model, I want to forecast for the future, and I know I already have a test data set to validate my predictions, and the test data set size is 104. That's what we saw on the top. right? It has 104 rows and 2 columns. So what I'm going to do is I'm going to take this and forecast it for the next 104 periods. So it's going to be the next 104 days because ours is a daily data set. So here what I'm doing is I'm taking like the model dot make future data frame and giving periods as 104, assigning it to a future object. So what it will do is it will create date object with 104 dates over here. I'm just printing the last few data, the tail, and show the data frame. Now what I'm doing is I'm taking the model and trying to predict the with the future data frame. The future data frame is all the date column, and I'm trying to predict with it. I'm getting a forecast. Now the forecast will have your final y-at variable, that is your predicted variable for that particular time, and you will have a lower and upper value, which is nothing but the 95% confidence interval of the prediction. Now, as I said, that I have explicitly given 95%. If I don't give that, it will be 80%. So let me run the output, and you can see the output of the forecast data frame. It's so see, this is basically 7585 is the predicted value for this state, and 6718 is the lower bound, and 8461 is the upper bound. Typically, when you're doing a forecasting, the forecasting may not be perfect, right? And that's why you need to have some kind of confidence interval on what can be the range of values, and that's what it is, the lower and the upper bound. Now I have this. What I'm going to do is I'm going to plot the data. I can use direct plot provided by Prophet itself. But what I'm going to do is now I'm going to manually plot it using the pandas concat function. So here what I'm doing is I'm taking this my original data set, and then I am taking the y column, and from the forecast data set I am taking the y at column. So I have the y and y at column. I'm going to take that and I'm going to plot it side by side. So once I plot it, basically you can see this is the blue one is the actual value, and the orange one is the predicted value, and you can see almost it goes in line with it. But you can see like the forecast, the actual value has some peaks whichever model is not able to model is not able to like predict properly. And that's quite possible because if we add more features to it, which I'll show in the next video when we do multivariate analysis, maybe our model comes closer to it. But here this is still a pretty good prediction because it has gone pretty close to the actual value. Let us with the with the confidence interval, right? So that's where what I'm doing is I'm calling the model object that I have got with, and then I'm telling plot forecast. So once you plot it, you will get it with the 95% confidence interval, right? So now if you see over here, the 95 confidence interval is in the light blue color, and the points, the black color points is the actual values, and this particular blue is the forecasted y at value. And if you see the if you take the confidence interval into also consideration, my previous plot did not have confidence interval. So basically you can see like a lot of points is covered by the forecast confidence interval. Some points are still outside of the range. And if you see the reason they are outside of the range, if you compare this year on year, only this year there were a lot of outliers. Otherwise most of the year the most of the points were surrounding this range, right? So wherever the outliers are there, this model did not predict it, but still it has done a pretty good forecasting. It has even got an understanding of the seasonality of that particular data set and everything, right? Trend is not there here, but seasonality is captured well. Now let's go, and what we can do is we can plot the components of the different prediction, right? So basically we have a model, what are the trend, what are the seasonality and everything. So here if you see the model, if you see the trend, it has predicted there's some slightly upward trend, and there is a downward trend, and again there is an upward trend, and there is kind of an stationary trend, right? There is no weekly seasonality. Maybe Monday to Friday the usage is higher, on weekends that's what is predicting. And if you see the yearly seasonality, you can see from May to September the demand is pretty high, and the reason is that those are summer months. Otherwise, in January to March or April, around the time frame, the demand is lower. Those are winter months, and we saw that in the plot itself. So here, what it does, it basically decomposes the output. Now, one point is like if you see the trend initially I said nothing but it works on a piecewise linear regression, and all these different changes is what is called change points. So this change points we can plot it as well. What I'm going to do is I'm going to take the data, and in the Facebook plot function, there's an add change point to plot method. Now, by default, what Profit does, it will take the 80% of the data, and then it will try to plot the change point. But you can increase it to 90% or whatever it is. Maximum it does 25 change points, right? But you can control it. Now, if you know your business very well, when are the change points going to happen, you can add your own custom change points as well. But here I'm going to just take the change point and plot it. So what I'm doing is I'm telling m dot plot forecast, and then I am telling on this object just add the change points, right? So when I print the output, you can see the change points, like these red lines that are crossing the plot are the change points. Now there's a one change point over here, there is a change point over here. Now if you see the graph on the top, if you see it almost like similar, there's a change point at this place, there's a change point here and here, there's a change point here. If you just correlate it down, or you can see those change points in this, but it does only for the 80% of the train data frame, right? So yeah, I can also do 90%. I will show you how, but typically change point gives you an idea. And what you can also do is you can add your custom change points if you know your business is impacted from some data points. That also you can do. Next, I'm just printing the kind of the deltas over here, and then I can also plot the change point change, whether it's a positive change or negative change. So what I'm doing is I'm taking that from the params object, I'm taking all the delta values, and then I am creating a function that will plot the change point. So here, if you see like different change points, as I said, it plots around up to 25 change points. But a lot of change points are almost like zero, so it's not plotting. So wherever it is, that is showing whether there's a negative change point or there's a positive change point. And as I said, you can override this change point, right? I can also print the change point output over here, and you can see what were the dates where change point had occurred. So that also you can do. Now, one thing I can do is I can also increase the change point from 80% to 90%. So that's what I'm doing. I'm having the same thing, but only thing in the profit model itself, I'm telling make my change point to zero point 0.9. Rather 0.8, which is the default, and then I'm just quickly doing it and printing it over here. So you can basically see now the change point will get increased to 90. You see earlier it did not have this change point. Now the change point has come to 90% of the graph. Now you can control that parameter, right? This also provides an very handy plotly function. So you can just import like plotly library from the facebook.plot, and then you can just plot it so that you can play around with the output over here. So when you have a lot of data, it's very difficult to visualize in the graph. So what you can do is you can go and narrow down on a particular range. Over here is a slider, so you can move the slider, you can go to a particular range, and you can visualize it better. So it's a handy function that you can use. Now, one of the thing is, now if you see from the beginning, we know our model is there, but how well our model is, we don't know. We need some kind of metrics that we typically use. It can be your RMSE or MAPE or other metrics. So in order to do that, what Facebook does is Facebook provides an diagnostic package. Now you can also write your own function and do it, because I showed you we have the Y value and we have the Y at value. We can use the Y and Y at value and write some functions and do it. But it also provides a handy cross validation function. And in the Facebook Profit, what I am doing is I am importing that cross validation. I am telling my cross validation, I'm passing my model object, which is M that we developed. I am telling use the initial 731 days of data, and you can control it. You can keep it however long you want. And I'm telling like give the prediction horizon as 365 days. So when I give it, it's going to take this initial 731 days and try to kind of do a cross validation and predict multiple forecasts over there. So let me show you. In this case, when it runs for 365 days, it's going to take 50% of 365 days, that is around 180 days, and then every 180 days it is going to run an internal cutoff cross validation, right? So that's why it is telling there are 5 forecasts, because it is 180, and 180 into 4 is close to 720, I think, like how much? Yeah, 70, and then the remaining is 1, so 4 plus 1 5, so it is creating 5 forecasts within this cutoff range. And I can just print the CV results output over here. Then what I can do is I can run from the Facebook diagnostic. I can take the performance metric package and pass this CV results over there. And if you see like the CV results, when I pass it and once I visualize, you can see all the metrics. So what it does is it takes like or different horizons. In 36 days, my RMSE was 501, 37 days 508. So it's showing the RMSE. The RMSE is pretty constant. So this is the RMSE of the model. Now what we can do is we can go and change some hyperparameters. Facebook does not have a lot of hyperparameters that we need to worry about, but there are few hyperparameters like change prior scale, or say if you're running for multivariate, you can go and compare the RMSE or MAP output and see which model performs better and take the model. So this is how you get the model metrics. So that's about it. In this video, I was mostly focusing on univariate analysis. In the next video, we will do a multivariate analysis using Facebook Profit on the same data set. So we will use the temperature column as well and try to model it. That's it for now. Thank you very much.